Welcome back to DemystifySci. I'm Shiloh.
I'm Anastasia.
This is the podcast where we search for the theories that are going to change the world. Live in the studio today, we have James Ellias from the YouTube channel Inductica. James has been concerned for a very long time with one of the biggest problems and one of the biggest holes in our understanding of the natural world, which is if light is a wave of electromagnetism, what exactly is waving? And so the conversation that unfolds is a conversation about the search for mediators in electromagnetism, gravity, electricity, all of the invisible phenomenon that don't have an obvious mechanical basis. And so in some sense, we are combing through various ether theories, but we're also asking the more broad question: what would it take to provide a theory for the mediation of these invisible phenomena that was satisfying to physics?
If you like what we do, consider coming over to patreon.com/DemystifySci, where you can support the project. We want to keep this forever free of advertisements and sponsorships and selling you weird little tchotchkes that you don't want or need. But we can only do that if we have your support. So come over to patreon.com/DemystifySci today, and for as little as 75 cents a week, you can support the project. We've also got another way that you can get involved, which is called Paradigm Drift. So once a month, we collect theories from you, the listener, and we give you the opportunity to present your theories to the world. We're recording the next one on December 5th at 5 p.m. Pacific, and so if you want to participate and you want to have a chance at presenting your theory to the world, sign up at the link below, and we'll see you there.
There is one more way you can support the project if you are already a patron, or if you hate Patreon for some reason, or maybe you just love music. You're in luck because we are super stoked to have vinyl copies of our latest record by our band, Secretary of Nature. We are super stoked on this music. It is cosmic. It covers all of the areas of reality that we can't cover in the scientific realm on this show. And if you're wondering what it sounds like, we're going to play you a little excerpt as we get into the conversation with James. So, hope you enjoy the conversation, and we'll see you next time.
This is a really good place to start, because something that Shiloh and I we've been doing this podcast for 5 years now. And we started doing this podcast because we were in grad school, and both of us independently arrived at a realization that there were things in fundamental physics that did not have explanations. If you ask somebody what a photon is, if you ask somebody what is charge, if you ask somebody, how does gravity actually work mechanically, there's this feeling that what you're asking them about is both a stupid question, or it's a philosophical question, or it's something that is irrelevant completely to the project at hand. And so we were like, well, that seems like an important thing to be able to answer. And so we set out on this project. And we're almost at 400 conversations, roughly half of them with physicists. And it is unbelievably rare to come across people that recognize the need for material mediators for fundamental physics if we are to understand things like light and gravity and charge and electricity, and why electricity and magnetism seem to have this weird relationship, and why the two of them together seem to produce light, and what is light, and all of these other things. And you are one of the small number of people, I think I could probably count on the fingers of 2 hands maybe over the course of 400 conversations, that gets it. And so I'm really excited, because it's an unbelievably satisfying feeling to find somebody who's like, hey, there are explanations for this. We don't yet know what those explanations are, but we are curious, we're exploring, and the stage is set for some kind of radical transformation. And so we're very happy to have you.
Well, thanks. Yeah, thanks for having me on, and for inviting me to your beautiful home. Yeah. I'll intro my particular approach to all of this and where it fits in with your interests. You've had on some people who recognize that there's something missing from the approach of modern physics, and you've said it yourself. It seems like fundamental questions of what's going on, what's really going on, what are the underlying causes of these phenomena, they're seen as stupid. And in my view, these flaws are they come from a bad epistemology, a bad theory of knowledge. And we can talk, and from that, I think it's a bad scientific method, really. And we can talk more about. I can tell you more later about what I think specifically the flaw in the modern scientific method is that led us here. But where it's led us is it's a lack of concern with identifying underlying causes. And what I'm working on is a new scientific method, basically. And it's a scientific method where instead of, basically, to put it very quickly, instead of guessing and checking, instead of the hypothetico-deductive method, it's observing and inferring. You make observations, and then you make inferences about what's going on underneath the surface. And when you do this, it makes it much easier to identify something like an ether. It makes it much easier to realize, oh wait, there has to be an entity there to commit these actions. With fields, all we're aware of are the actions. What's committing the actions? It can't be nothing. The action can't exist on its own. That defies what it means to be an action. An action is an action of something upon something.
It's actually super insane how often I run into people who are like, "You're an idiot. We already have fields." And then I have to be like, "I understand why you think I'm an idiot. Because you're right, we do have fields, but maybe you don't realize that a field is just a vector whose magnitude varies with its location in space, which means that it's a measurement of, like you said in one of your videos, it's a measurement of a property, a quality of something else. And that something else is a question that until we recognize hasn't been answered, we have no chance of addressing. And and people will be like, oh, well, who cares? It doesn't matter. And it's like, well, like you pointed out this in one of your videos as well, if we didn't have this idea that molecules were little bits of things that could recombine, would we have all of the advances in chemical technology that we have today? I mean,
yeah, we would just have more and more complicated abstractions to relate the different chemical reactions to one another. And they might even be useful in a limited way, but they wouldn't identify the fundamental cause. And we'd never come up with something like nuclear energy, because you'd never know about the atom and you'd never know about the nucleus.
But I wonder if we can't start from the very core of this, which is that when I have these conversations with people, they're like, I don't understand why a force can't be fundamental. They're like, there's just, like, I literally, like, I was staying with my brother and...
Star Trek ruined their minds.
What's that?
Or Star Wars.
Or a force field from Star Trek, or the Force from Star Trek, or Star Wars, yeah.
Right. And so there's not really like it's not hard sci-fi, and so nobody's actually talking about the details of how the force fields work or how the force works inside of either of these. But I was staying with my brother and his wife, and we were talking about this a lot because I'm like working on this book, and they're constantly asking what I'm working on, and I'm trying to explain like electromagnetic radiation and the problem of the lack of mediator. And my brother's sitting there, and he's like, I don't understand why there's a force. The field maps the force. Like, yeah, exactly. And so I think that would be a really good starting point for this conversation, which is that there is a huge contingent of people in the world that are like, yo, it's forces. Those are fundamental. What's your problem? Why can't a force be fundamental?
So yeah, I'm really glad you asked this question, because answering it is part of my solution. Part of my scientific method, this book I've written, is that you can get on my Patreon page by supporting Inductica. Part of this book is a theory of what I call broad physical categories, which are fundamental concepts that allow us to make inferences about the world. So what should the concept entity mean? You might say, well, like, it's kind of obvious, right? I don't think it is. I think when you split the world up into certain concepts, it makes it harder to think about reality. For example, if you think force is if you think an action can be a force, like an action like force can be fundamental, it makes things confusing, because what is an action? It's when one thing changes as a result of another thing, as a result of another thing's properties. So otherwise the action is random. Otherwise it's just, oh, this thing changed. Well, why did it change? Did its parts rearrange themselves with respect to one another. That's one way it could change.
But also, you keep saying it too, right? Like
there's an it, yeah. In order to be
you can't
changed, there needs to be an it there.
It's
yeah.
like an action is inconceivable fundamentally without an actor.
An actor and a object of the action. Yeah. So this is the kind of thing that leads us to these broad physical categories and leads to an objective conceptualization. There are right and wrong ways to use these words. When you use them rightly, it makes everything much easier to think about, and you can start delving deeper into the nature of the ether, for example. And when you get them wrong, you end up, for example, not thinking there is an ether. You say, oh, well, it's just the force, right? And you forget this whole context where it's like, well, you can't have a force without a thing being forced, without a thing exerting the force.
Can you see why people accuse us of philosophy?
Well, but like it's not like that is a profoundly complementary accusation. You need philosophy to do physics properly. You need to get clear on these fundamentals before you engage in scientific methodology. Before the Enlightenment, science was impotent because they had a bad philosophy. But then they started reading Aristotle and they started having a good philosophy, and that's what enabled the whole scientific revolution.
This is almost a bigger point that I feel like framing this in, which is we've done an entire podcast with another gentleman. It was Michael Vassar, I believed, about how people have, in some ways, not kept up the tradition of practicing thinking properly, which is strange. And he, in some sense, pinned it on the evolution of mass education, which was really aimed at putting people into slots bureaucratically. But I find it relevant because you reference the Greeks, and I think the Greeks had a very different way of approaching education, which was based on learning how to think by comparing arguments. And that's something that you don't really have today. And we probably should, because the problem is you can make it all the way through a PhD program without comparing arguments. You can get really good at learning things on a chalkboard and processing logically the formulas that are on the chalkboard under any given number of circumstances. But if you're not actually comparing arguments, then you don't exercise a muscle in your brain that I think that the ancients identified very early on was absolutely essential to a successful polity and a successful thinking body, engineers, scientists, really just civilization in general. Because otherwise, everybody's just kind of following the dotted line and nobody's steering the ship.
Yeah. No, yeah, and no one's steering the ship. In modern physics, they're following the philosophy of roughly the early 1900s without knowing that that's what they're doing.
That's critical. Yeah,
yeah. So because they haven't thought, and why? It's because they say, "Oh, well, you're doing philosophy." Well, but you need to. You're not doing philosophy. And you're not doing philosophy. Well, that's gonna, like,
you have a doctorate of philosophy. Like, what the hell's going on? That's one of the craziest holdovers for me.
Yeah. This is when you say that you're not going to think about these fundamental issues, you're basically saying you're not going to think about it. You're going to use the standards of the people in the past, and it just so happens that the standards we're using are the standards that they had back in the 1900s, basically. We're just using them without knowing that that's what they're using.
And those people were brilliant too, but so much has happened, especially observationally since then. Like I'm reading Max Planck's theory of heat radiation right now.
His theory of everything.
Basically, he did try to make it into a theory of everything, but that's one of the equation that he deduces at the end of 300 pages is one of the most referenced equations in all of physics.
What's the equation?
It's essentially giving you a means to identify the temperature and frequency.
Is that really gnarly one?
It's a really gnarly one, but based on temperature and frequency, you can identify, or based on the intensity of light, you should be able to identify the temperature and frequency.
It's like a totally brutal equation. Law?
It's related. He uses Wien's. The Wien field to deduce this, but it's a generalizable theory. The problem is he makes some insane assumptions in it. It turns out that the equation is actually extremely relevant to these particular experiment that he based everything on, which is these black bodies, which is a very particular situation with these perfect absorbing chambers and so forth. But he tries to universalize it to all chambers, right? So even mirrored cavities. And without getting into the weeds about this, what's fascinating is that so many people inherit this law as a universal law without having any clue of how it came to be universalized, and it's broken fundamentally. But Max Planck is such a superhero of physics that not only does no one have time to go back and read this 300-page proof,
Mhm.
but nobody has the will to dethrone this champion too at the same time.
Yeah.
He's an unassailable figure. And the consequences of the mistaken universalization of essentially black body physics to all materials, it's just seems sort of trivial to people, right? Um, so there's something about these people being brilliant, not having access to all the information we have now, but also our inability to reprocess and pick up the problems where they were left off in the early 1900s, say, and develop them into the future. There's something about how when you go and do a PhD, you don't have time to actually sit down.
Yeah.
You don't have time to really think about where these fundamental ideas came from. Like I use the Navier-Stokes equation a lot in my PhD work. I had no time to understand who these people. I literally didn't know anything about them or where this came from. I was just like, this is important for diffusion, blah blah blah, right?
Right. Right.
And that's a real shame too, because to be
Do
honest,
you understand that equation now?
not as well as I should have,
Okay,
right?
because
That the
otherwise I was
time
going to ask you
the
about
train has left the station. Yeah,
it.
yeah, the train has. I mean, yeah, if I need to work on it, like I don't work on that topic anymore, right?
Okay. Yeah.
But of course, it's a extremely useful and universalized pattern in nature in
Yeah.
many sense. Like all the transport phenomena are very universalized, and so yeah, the next time it crops up, maybe I will go back and actually study it. But
Right.
that's the problem: is that you just sort of accept these relationships, these laws, and these fundamental discoveries. And with respect to the ether, many people just, oh, the ether's been just like they just proved that it's
Yeah.
stupid. Forget
Right.
about it.
Right.
That's one of those things.
Yeah. So in Inductica's approach, actually, I'm really glad you brought up this problem because Inductica's approach has a specific solution to this, which is to go back and actually reprove all of it. And right now, it's, you say no one has the time. The reason no one has the time is because, number one, no one's has done it. No one's actually assembled all of our physics knowledge in an order that would allow someone to see the observations and reasoning steps that allowed us to see that it was true to begin with. So if there was any mistakes in the past, we wouldn't know about it because we're only taught the result. We're not taught the observations and reasoning steps that led to that result. So part of what we need to do is do all of that hard work to actually understand why did we accept these equations to begin with? And once you answer that question, you'll actually understand much better what they mean. So in the Navier-Stokes equation, or I guess I'm mispronouncing it, French Navier, haha, oui. So that equation, I understand all of it except for the convection term. Like I've actually gone through and identified each item, and so for example, I'll just give one example. If the divergence of the fluid is negative, it means that the fluid is flowing in to a certain location. If that happens, the density will increase. That's an example, and it's hiding, and it's just there, plain to see if you break it down. It's not easy, but like it's there. If you drill down hard enough, you will identify the real physical meaning of these equations. And incidentally, the Navier-Stokes equation might be it's another model of the ether. You guys had Chantel on a while ago who has an elastic solid theory. There's a whole nother theory that involves a fluid theory of electromagnetism. And so understanding what these equations mean, what they really mean, instead of just like, oh, well, how do they get right predictions or not? That's great if they make right predictions, but what do they mean in terms of cause and effect relationships? In terms of fluid is moving into this point, so the fluid gets denser here as a result. Something simple like that. It's not simplicity that it's important. What's important is that you understand a cause and effect relationship. And when you do that, you identify new properties of the ether or whatever it is you're studying. And when you identify new properties of the ether, you can manipulate, control them. And that's how mankind gets new powers. It's not just from making new predictions, it's about identifying new phenomena and being able to control them.
Okay, so that's interesting because on some level, it doesn't totally hold true over the course of the last 150 years because no one really understands electricity. Nobody really understands charge. We have really, really good equations that govern how it will move through systems and circuits.
Mm-hmm.
But this problem of like, well, what is electric current? Like, what is actually happening that produces it?
Mm-hmm.
What causes charge to emerge in a system and be transferred? Deeply nebulous without a material mediator.
Right.
And yet, I mean, look around.
Some
It's like
people
we're
might be
surrounded by all
listening,
these
Nastia,
things.
by the way, and say, well, it's the motion of electrons.
Well, yeah, and I think that is true, but then you go down the rabbit hole of like, okay, well, what is an electron?
Yeah.
And then you end up at this weird place where it's like the current moves at the speed of light, the electron drift in the circuit is at the pace, I think it's slower than like a garden snail's pace. I like went through and I calculated it. And so all of these things don't work. And then you have the heavy side thing of the fact that, you have that electricity doesn't flow in wires. It's the Poynting vector that travels outside of and it's just
that's where the energy flows is outside the actual wires. Yeah.
But I don't think that clarifies or explains because then you're like, okay, well, what is energy? And so each time that you try to explain it, you get to a place where you are stuck with something that is still immaterial and still causeless. And so we've managed to get really far without material mediators in these spaces. And so the idea that the only thing, I agree with you fundamentally that we do need to have models, physical models, things we can visualize, things we can understand. And yet I'm also struck by the fact of how far we've made it without them. Like, what do you make of that?
I mean, you by identifying further and further mathematical abstractions that make predictions, that is useful. You can now make predictions. But the way that you really gain new powers is by identifying new entities, in this case the ether, and new causes, in this case the way that each bit of the ether acts upon each other bit of the ether to produce a change. The analogy I would draw here is to, once again, the atomic theory of matter. If they never accepted atoms, they would have just kept coming up with more and more complicated mathematical abstractions to describe the relationships between the mass ratios. And that would have kept making small little bits of incremental process. And they may even think they're identifying new physics. And in a sense, they are, but it's not new entities like atoms. It's not new cause and effect relationships like the joining and disjoining of those atoms. And once you identify those underlying entities, those underlying cause and effect relationships, you gain new powers that would have been unthinkable before. Now we can custom make special molecules that we never would have been able to make without an atomic theory of matter. Further, just understanding the atom allowed us to probe into the atom itself, which gave us nuclear energy. All of that would have been closed to us if we had just focused on more and more complex math to describe the reaction ratios.
I like the way biologists get it. I like how they get it because it's always about structure and function, and they might refer to some binding kinetics and stuff, but at the end of the day, you're like, binding a what? And they're like, well, these
Yes.
little things, this lock fits in this key, and or this, turbine's being turned by this whatever. They have the notion that structure is important in a way that fundamental physics seems completely uninterested in.
Yeah.
Which is just, at the bare minimum, it's kind of tragic. Nastia came up with this absolutely brilliant version of this where she's like, you could imagine a point where the biologists had the choice. They had a really good Mendelian sense of inheritance. They realized that there was some probabilistic version of reality that could be predicted. And they could have just stuck with it. There's a genetic field inside the nucleus.
A genetic field.
Right?
Yeah.
You know what I'm saying?
A genetic
they could have got
abstraction.
100%.
Yeah.
It could have been predictive. It
Yep.
could have been probabilistic. It could the wave function of the genetic field could collapse sometimes when like at the moment of conception, well, it just collapses, It's spooky and weird, but we just can't understand stuff down there. It's just too weird for us to comprehend. And but it's the most accurate predictive model that mankind has ever come up with. Genetic fields are real.
Yeah. Yeah. So that's a really good analogy. So the next question I ask, once we establish these philosophic fundamentals that like we should be looking for the entities and the actions, where do we go from there? And that's where like my method of induction comes in. And so specifically, some of the work I've done is first of all to prove there's an ether. Right now, I think a lot of times the way it's thought of is like, oh, this is a hypothesis that makes a lot of sense. It ties a lot of the pieces together. We make these arguments like, well, there has to be something doing the acting. Yeah, but how do you know that that something is actually a medium? How do you know, for example, that charges aren't shooting something out of them? Like, sure, there has to be an entity, but how do you know the charges aren't shooting like a projectile out and acting on other charges through that? There's a way to do that. So my argument basically goes something like this. When you look at the equations for electromagnetic phenomena, what you see is that if you so for example, if you look at the electromagnetic wave equation and you break down what it really means in the same way I broke down the divergence of a flow field, if you have a flow field all coming into converging to one point, the density will go up. If you do that same kind of mathematical reasoning for the electromagnetic wave equation, you find that each location changes in its electromagnetic properties in a way that depends on the electromagnetic properties of neighboring locations. That's an action. If there's an action, there's an entity doing the action.
Explain why that's an action.
Because, well, that's what action means. An action is when one entity changes in accordance with the properties of another entity.
And so basically you're saying that if the field properties at a certain location were completely uncorrelated to what was happening around it, then you could maybe say that it's like there's not a chain of cause and effect that has led to this thing happening, but you're like, but because of the fact that you can look at it and you can draw a map of all of the things that are converging to influence this point, all of the sudden you have a map of influence, and if you have a map of influence, you have a map of action.
Yes. Yeah. And you know that there must be something doing the acting. And so at each of these locations where the electromagnetic wave equation holds, there is an electromagnetic ether.
I really love that. Like, I've never heard it put exactly like that, but I think that that's a really great example for what it means for there to be evidence of action. I like that a lot.
This is why I don't think, to toot my horn here, I don't think people have, actually this isn't true, but in the last 50 years at least, no one's really thought about it like this. It's been thought of it this way in the past. I'm not the first one to think of it this way, but I think I've made specific innovations that haven't been done before. And that is to specifically think about these fundamental concepts: entity, action. What is an action? And I told you that that's the mark of an action. When one entity changes in accordance with the nature of a different entity, that means the entities are acting on one another. That's the mark of an action. That's what we mean. You have to get clear on these, and then you can get clear on the nature of the ether.
That's really funny because the phrase that everybody uses is correlation does not imply causation. And yet what you're basically saying is you're like, well, actually, if you dig down far enough and what you're trying to do is you're trying to figure out something deeply obscure in terms of physical action, then correlation does to some level imply causation, because how else could it be?
Well, that phrase correlation doesn't imply causation. It's just warning you to say that there could be some other causal vector. There should
it's also not true. Like sometimes it does actually.
Well, but sometimes it does. But they're just warning you to not always just presume that. Yeah. It's a good rule of thumb.
Yeah. It should say correlation does not always imply causation.
Yeah, maybe something more like that.
Just not as slick sounding.
Yeah. I mean, that's kind of what as far as I know, that's what they're saying. They're not saying like ignore all correlations.
It does come across that way. Yeah. Right, can I scroll this back though? Yeah. What's the alternative? So you're kind of promoting this alternative approach to science, what is the standard method? Like, how would you
Okay.
lay out the standard method?
Yeah.
Because most of us think scientific method just means you do experiments and test your theory, and then everybody votes, and then it's
Yeah, the voting part.
and then
I
it's
mean, yeah,
science.
it's a consensus. We need a consent. Oh man, that
Okay.
makes me so mad because it just completely invalidates the whole scientific enterprise
All right. So
when you
so tell me
put consensus in. But yeah, so yeah, with my view of the current scientific method that we need to replace is that it's the hypothetico deductive method, the guess and check method. You make a hypothesis. If your hypothesis makes correct predictions, then what? Then you're a little more confident of the hypothesis. It doesn't prove anything. That's number one. Number two, I actually think that this scientific method is responsible for the state of physics today. And the state, specifically, I think the essential error of modern physics is that they don't think about the underlying entities and actions that are responsible for the phenomena we see. I mean, they
Why is
reject the
that ruled
ego.
out by the deductive method?
So yeah, it's not obvious how the hypothetical deductive method leads to this. The reason is in the hypothetical deductive method, you can never actually prove your hypothesis. The only utility of the hypothesis is whether it makes correct predictions or not. So if this is your only scientific method, you have no reason to prefer what's actually going on over a hypothesis that just happens to get correct results. Why don't you prefer it? Because you can't tell the difference. You can't tell the difference between just some abstraction like, oh, maybe it's all made of strings, or maybe there's a space-time that bends. These abstractions, you don't, as far as you know, the only way to validate it is if it makes correct predictions. And as soon as it makes correct predictions, you accept it. And if someone says, well, are you really sure there's an actual space-time that's bending? Like, does that even make any sense to talk about space bending? Like, and they say, well, all of that doesn't matter because this theory made correct predictions. And so when you're only concerned with making predictions, you become unconcerned about what's actually going on because the only usefulness of these abstractions is to generate correct predictions.
Seems to me though that there's two pieces of this. One is being obsessed with predictions, which is an engineering value structure. That's fine. We can deal with that. But also the irrational hypothesis,
Yes.
the immaterial hypothesis. It's like I don't know that the hypothesis itself is the problem so much as suggesting hypotheses that have no material possibility.
Yes. Yeah, so I'm not against let me make this clear. I'm not against hypotheses.
I see.
I'm against this guess and check method. So I'll give an example to differentiate how I think of this. So think of Thomas Young's double slit experiment. So you shoot light through two slits. The light interferes with itself, and this proves that the light's a wave. There's two ways to look at this. If you look at this through the hypothetico-deductive method, then someone would say, oh, Thomas Young expected the light to interfere with itself. His prediction came true. So maybe his hypothesis is right. And so that doesn't give you that much certainty. But now reframe the same thing a different way. Frame it this way. Say, I shot this light through two slits. The light canceled itself at certain locations and added to itself at other locations. That is a property of a wave. It's a wave. And by the way, it's a property of a wave that entails all of the other properties of waves. It has all of the properties of waves, so it's a wave. The end. Simply by reframing the way you think about the exact same observation, you can now have certainty of the conclusion instead of just this vague hypothesis that happened to get the right results.
So this is really interesting, actually, because Huygens, almost 150 years before, had made the same claim that light was a wave, but he was working with single-slit diffraction.
Mm-hmm.
And so he, again, did the thing where he was like, look, this is what it does when you put it through a single slit. This is what water does when you put it through a single slit. Ergo, light must be a wave. However, there was a lot of different ways that people could modify particle corpuscular theories
Mm-hmm.
to give the same results
Mm-hmm.
as the wave-like nature. And so the reason that Young was dominant eventually was because Young used a double slit, and the double slit mechanics are so difficult that no one could propose a functional corpuscular analog that could behave in this wave-like nature
Right.
without without just completely losing themselves in the details.
By the way, people were super mean to Thomas Young.
Oh my god!
Really?
Oh
Yeah.
my
God.
god! I mean,
Yeah, I
you
heard
should
people. Yeah.
hear. You should just read some of the London Times pieces or whatever it is.
Scotland, I think.
Scotland. I think there's pieces in the London Times about him. There was this one popular journalist who was just so appalled that he thought he could stand up to Newton, who was like their national hero, you know? And
Like, I have a feeling that what Shiloh's pointing to, which is that Thomas Young comes up with this demonstration and everyone's scrambling to figure out how they can save Newton's theories, really comes down to the fact that theories in general are kind of socio-psychological phenomena more than they are really about any of the details. It's like, who are you?
especially about invisible phenomena.
They don't have to be, though.
I'm afraid they do. Like, this is okay. And I can make this argument, which is that, like, scientists are humans. And scientists are generally people that are not paid in money. They're not paid in nice houses and nice cars. They're paid in renown. They're paid in being the ones who are associated with the ideas that are correct. You will never... And there's also this other thing that's acting, which is, number one, we acknowledge that there's an uneven distribution of ability, and so that there's some people that have brilliant ideas and some people that just work the cleanup crew. This is like the Kuhnian paradigm thing. And so everybody wants to be on the right team, because if they're on the right team with the right genius, that makes them stronger, more powerful, more historically relevant than being on the wrong team. And so I don't think that you can erase these natural human tendencies of A, wanting to be the guy who comes up with the right idea, and B, wanting to be the person who associates with the guy who came up with the right idea.
Yeah. I mean, you can't erase the temptation to be biased, but you can have integrity. You can personally choose to put the truth first.
I think that
So it
people
doesn't have to be
genuinely
that
thought
way.
that it was corpuscular. Like, I don't
Oh,
think
yeah,
that people
yeah.
like.
But any of those who did so in the face of the contrary evidence, when they could have known better,
They
were
couldn't have-
being dishonest. They
But-
were not exercising scientific integrity. And this is
I
something
think they just
that,
thought it was an exceptional situation. Like, I've told you, I've been studying this Planck stuff lately, and I really don't want to get into the weeds on this, but, you know, there are people at the highest positions in certain arms of physics who reference this particular work in a way that they believe what they see in the cosmos is exceptional. Like they recognize that there's no way that this particular light phenomena has ever been seen outside of this very specific black body experiment.
Mhm.
But when they see it elsewhere, not from this particular black body situation, they just think, oh, well, you know, it's a special situation in this case. Like, I'm talking
Right.
about the cosmic microwave background radiation.
okay.
Or like neutron stars.
Or just stars
or black
in general.
holes. Pardon the interruption, but I have to ask you for a favor. This is a project that is supported exclusively by listeners. We do not have advertisements. We do not have sponsors. We are not selling you digital beds and supplements of questionable provenance. We simply ask that you come over to patreon.com/DemystifySci and sign up to support us for as little as 75 cents a week. In return, you get to join our weekly Sunday hangout, and you get to live with the warm feeling of satisfaction of having supported something that you want to see more of in the world. We'll see you at patreon.com/DemystifySci.
So you're saying you're saying that the temptation to make exceptions, when your theory doesn't work in certain cases, there's the temptation to just make exceptions. You're just saying,
Yeah, and I don't think they're bad.
that actually happens though. That legitimately happens. Like, your theory's right, but then in certain cases there's additional factors that make it so that your theory on its own doesn't make the right predictions. So, I mean, I'm not saying that everyone who gets things wrong in science is being dishonest. I'm saying that honesty is possible.
I think it's
And
possible
these
to
mistakes are easy to make, though, even if you're being honest.
just to be like perfectly clear about this, what I'm saying is that when you look at thermal radiation from a gas or a plasma, you get individual line frequencies. When you heat a solid or liquid, you get a thermal spectrum that's a continuum, and specifically with black bodies, you get this very particular fingerprint. It's a very, very special curve, power curve that you get. But they'll look at something like a star and they'll say, well, it's gaseous plasma. Even though there's no way on Earth there's no way in the universe that anyone has ever observed other than a star, right? So the argument is, well, no, gaseous plasma can make black body spectra. We know that because stars are gaseous plasma. Well, how do you know stars are gaseous plasma? Because they must be. Like, it's the exception. And I believe these
Don't they just
people
know that hydrogen is a plasma phase at the particular temperature we're reading from?
Well, the temperature argument comes
Comes
from the
from
black
black
body
body.
radiation.
Yeah, right. So, I mean, yeah, with things like this, you have to be honest about like the plausibility of your argument and how their story coheres with itself and it seems likely, but they have to acknowledge that they haven't fully grounded their reasoning there. But what's your deeper point you're making here? I think I'm still missing it.
Oh, my deeper point is just that I don't think these people are dishonest. I've met enough of them and I've put this in front of enough people who genuinely believe that stars are the exception. They're the one place in the universe where gases do provide black body spectrum.
Okay.
Like they actually believe that. It's a belief. It's a true belief. It's not I don't think that, even though it's completely preposterous proposal and there's no reason to believe that, there's no empirical reason, there's not even any theoretical reason, because I could spend an hour walking
Seems
you
like the
through
reason
that.
is that it coheres with itself. But I'll take your word for it for now that there really isn't a good reason for it. And you think they're still being honest, even though there's no good scientific reasoning behind their
Yeah, because Planck said
work?
it's okay. He said,
But that's not science.
well,
At
that's
least
all
it's
they
not good
learned, you know? That's
yeah.
all.
I mean, the way we're taught science does not encourage you to think for yourself. So I mean, that's part of the problem is you're taught all this stuff. So I see what you're saying. It's still like you still want to cut them some slack because that's how they were taught. Yeah, I get it. But
I just think it's
however
different than lying. Like, lying is
Yes.
sort of malicious. There's probably a couple of people.
I think there are some.
There's probably a
yeah.
few people who know what better, but I think for the most part, people have just grown comfortable with these mistakes over the last century or so. This is just one of many examples I could bring up. It just happens to be one I've been studying a lot lately. But where people just grow very comfortable with things that don't make sense. I mean, the ether is another one, right?
Yeah, exactly.
There's examples of this everywhere, where you just get comfortable
Yeah.
with something that's not right. And I don't think it makes you, even when faced with the facts, I don't think it makes you dishonest necessarily. It might make you naive. It might make you maybe, I'm not going to say anything bad about these people, but yeah, there's some other elements. And honestly, I think that, I'm going to just throw this out there too, just for shits. I think that it bends with the same type of property that allows humans to form tribes and maybe even join cults, which doesn't seem to actually trend with intelligence. So if you look at people who join cults and who, let's say, jump on radical political ideologies and do things that in retrospect are obviously crazy, it doesn't bend with IQ, which is unbelievable. Like, smart, really, really, people with much higher IQs than me join stupid cults. And that's a weird axis that I don't feel like we've totally accounted for in terms of how these knowledge structures are set up. Because people will jump on things that are obviously insane, but they're still on paper great at calculating or whatever.
Yeah. I mean, my view, I've asked myself questions like this before, and my view is just that I don't want to delve really too much into the psychology of my opponents because I kind of don't even see them as opponents. I think they're just going to be like those who don't think there's an ether. They're just going to be left behind because they're wrong. The end. Like I don't really either if I'm going to try to convince as many as I can, and those who are not convinced, I'm not going to spend time judging them. Maybe they're dishonest. Maybe they just made an honest mistake. I don't care. I'm too busy trying to figure out physics.
But this is what's crazy. Okay, so I think that this is really important because earlier you said something where you were like, the reason the Enlightenment happened is because people finally started studying Aristotle. And I'm like, bro, it's the exact opposite. It's the fact that Aristotle was the only possible scientific method that was available. And the Enlightenment actually began when people started saying, hey, I think that Aristotle's conclusions about nature are bullshit. And the church was deeply, deeply like intertwined with Aristotelianism to the point that I think that it was Pierre Gassendi was this priest who was the first one who was able to actually write this full treatise about the fact that Aristotle was wrong and get around the church because he was such a political player that he was able to point out that like, hey, we can actually abandon Aristotelianism without undermining the authority of the church. He was sufficiently highly placed that he managed to do this while at the same time there was a bunch of radicals in Paris that had formulated this like anti-Aristotelian society, and they were chased out of town by the gendarme because they were they were organizing protests, there were people in the streets, and the state was basically like, no, we're not objecting to Aristotle. And so I think that that's a really, really important thing because what we're talking about here is we're talking about 1,400 years of kind of cultish behavior because there is a centralized thesis that takes hold. And it's the same way that, we talked at the beginning where it's like, okay, well, so people accuse us of doing philosophy instead of doing physics. And we're like, well, you have to do philosophy if you're going to do physics. I think you also have to do psychology because there's something about this where you talk to people and they're, like Shiloh's saying, brilliant people, far higher IQ people than me. And they're like, forces are fine. I don't understand why forces can't be fundamental. I don't know what you're on about.
And they look at you like you're the stupidest,
yeah,
whoever.
I think a lot of times. Oh, sorry. I think a lot of times when they look at you when you're stupid like that, I mean, like that's ultimately an epistemological authoritarianism.
But that's the thing we have to figure out. That's the whole thing.
I don't need to figure it out. I just ignore those people who do that. And I'm not really even that interested in differentiating those people from those who are just somehow making an honest mistake. I just want to figure out physics. I'm not that interested in judging these. Let me make a quick correction to something I said about Aristotle, though. Sure. What I really should have said, this is my view of the history, is Aristotle, the reacquaintance with Aristotle started the Renaissance, really. It got us out of the Dark Ages. Then the church, but who were the people who studied this stuff? It was a bunch of people associated with the church. And when people wanted to take steps beyond Aristotle, not in contradiction, like I don't think Galileo, for example, was in contradiction to Aristotle, not in essence. Obviously, he disagreed with Aristotle on a bunch of physics, but not in essence. Galileo is fundamentally Aristotelian in that Galileo believed in getting knowledge from observation, as opposed to the Platonic tradition, which is more of the Cartesian way of doing things, where you make deductions from allegedly obvious starting points. And now we know that's not the way you do science. You do it through observation primarily. So in the deepest sense, Galileo was Aristotelian, but he wanted to go beyond the achievements of just Aristotle. And of course, the way things always go is that the entrenched mediocrities who just repeat the wisdom of the past were against the people who were the innovators. That's just that's just how it seems to go in history.
Wasn't Aristotle into the forms too?
He was, yeah, I was just about to say that. He was, like, he was into realms, like the sublunary and the superlunary realm, and the idea that there are these two things. Like, you're right to some degree about the fact that he was separate from Platonism, but he did have a tendency to believe in these, like, form-like realms, where it's like the superlunary realm is the heavens, where everything is perfect and nothing ever changes. The sublunary realm is like the place where the heavens come, and there's like this corruptible reflection of the processes that happen in the heavens. And the thing that happened in the 1100s was not that they came back to Aristotle. Like, the reason that I know this is because I literally spent like 6 months of my life studying this exact moment because I was trying to figure it out.
Yeah.
they translated Lucretius's De Rerum Natura. They found it in the basement of the Vatican somewhere, and they had gotten into ancient Greek translations or ancient Roman translations, and so they translated it and they got the atomist perspective. And it was basically comparing and contrasting Aristotle to the atomists. And that was the first time that they were like, oh, fuck, there's a different idea. And that was the first time that people even began to slightly criticize Aristotle, because he was basically the main player in making sure that the atomistic theories did not take hold in the ancient Greek world, because he fucking hated Democritus. You can find in the writings where he's just these people are soulless assholes that have no sense of spirit because they believe that everything is atoms and void, and that's not possible, and their physics is bullshit. And the church loved Aristotle because Aristotle had the soul. And
But he
I could talk about
he
this
did
forever.
care about observation, though. I
He
think that's
did,
the relevant
yes.
point.
Yeah, I
That is
think
a relevant point.
when I talk about this, what I'm trying to say is that you can the core of Aristotle is this positive. It's not even an attempt, it's a success in my view, because it's the essential. Essentially, what do you think the scientific method is? And Aristotle said it's primarily observation, not primarily deduction from allegedly obvious starting points. And that's the core. And if you find places where Aristotle was inconsistent with that, that's just places where Aristotle was inconsistent. You're going to find places in the niches where I probably contradict myself, but in those cases, I would defer to the core of my belief system. And so when I say Aristotelianism, I'm referring to that positive core, or what I believe is a positive core, even if you find places where he's not living up to that ideal.
Yeah, and I mean, I think that the nuances of it are super, super tricky. But we've wandered afield.
Yeah.
let us return. Shiloh, can you guide us back?
I mean, I have a couple of things that I'm interested in. You said at the beginning that you had surveyed a number of approaches for solving the ether problem, so maybe we can work towards that. I personally have a suspicion, I'd like to hear what you think about this, that the word ether is bad branding at this point. But based on how unconcerned you are with the acceptance of this new paradigm, perhaps it doesn't matter as much to you. But I guess I could
I want to
substantiate
convince
that.
people. Yeah, but
I mean, yeah, I'm not sure how much I need to substantiate that, but I have, in my experience, the feeling like two things happen when the word ether is brought up. One, you're an idiot. Don't you know it's already been disproven? Two, oh, you're one of those alternative types, which is you're one on the that's a fringe idea or something, right? And I think that those are very heavy baggage to bring into any serious conversation that I personally choose at this point not to bring to conversations with academic types. And I have found some ways to talk around it.
Okay.
But I have a feeling that perhaps the road forward is not using that word. But
And I want to can I
please,
piggyback off that?
Please do.
I think that there is a deep psychological process by which ideas are passed along. And Shiloh and I were talking about this just recently because we're working on this. So we threw a conference about cosmology. And as a consequence of the conference, we're working on a roadmap for the future of cosmology with some of the speakers and organizers. And as we're going through it, there's this deep desire to set ourselves out as the alternative cosmology community. And I'm like, do not do that under any circumstances. Do not call yourself alternative. Do not call yourself outsider. Do not call yourself fringe, because these spaces have an immune system. It is not just the human body that has an immune system, it is also the human mind. And as soon as you...
Societies have immune systems. Yeah, we're very tribal people. We have fundamentally tribal neurochemistry, I believe. Well, I don't know. You identified yourself as an objectivist as soon as I met you.
That's a belief. That's not a tribe.
Isn't it?
I mean, if the tribe, I'll tell you this, if the objectivist tribe were to repudiate the principles of objectivism, I would leave the tribe and I would say I'm the only true objectivist.
But they couldn't definitionally, because they would, so like the
Yeah,
tenets
I
are written
disagree.
out.
I think objectivism means a certain thing, or any ideology means a certain thing. And if everyone misunderstands it, then they aren't the real objectivists.
But there are real objectivists, which can be identified.
Yes, but it's
Which would
up
be a
to
tribe.
each individual person to judge for themselves whether or not that person is adhering properly to the principles of objectivism or anything else, whether they're adhering to the proper scientific method or whether they're really an ether theorist, whatever you.
So institutional societies have encoded these, perhaps. They've encoded it in a way. There's also subtextual encoding of these behaviors. And if you spend any time working in an academic setting, you become very sensitive. Maybe, I suppose, a sensitive person would become very aware of the borders of this immune system and the immediate, almost quasi-emotional institutional reactions against things which seem to challenge the basic tenets of the institutional approach.
Yeah.
And how much effort is put in during the institutional approach to getting ideas past the immune system. Like, this is a thing that everybody who writes papers into high-impact journals obsesses over. It's not the fact that you just come up with some experiments and you're like, I have a brilliant idea, and then you send it to Nature.
How do I communicate it in a way
No, it's literally
accepted?
like, who do I cite in order to support my argument so that the institution accepts the presentation?
Yeah. I mean, all of this is just a problem with institutional the epistemology that's currently accepted. I think it's true that people have not always lived up to a good objective scientific method, and in fact and they certainly don't today, but science is about identifying the truth. And if you fail to identify the fact of the matter, if you dance around it and call it, a mediator or something instead of an ether, because that's what you're talking about. You're talking about an entity at each location. What's the word we used for that? It's an ether.
Well,
you're simply not being clear. You're simply not being clear. And
well, I guess I could argue about it. Yeah.
Communicationally, you might strategically use that word. You might say to yourself, I will not use the word ether unless I have time to talk about the Michelson-Morley experiment and how it didn't disprove the ether. I won't use the word ether until I maybe have time to make the clarification that it's not made of some substance. At least I don't think it is. It's not made of carbon or fluorine or whatever.
It's not made, yeah.
It's probably some new kind of entity that hasn't been discovered before, that hasn't been identified yet. You might strategically make these decisions to make it clear to the people you're communicating with, but you have to be clear on what you believe. Otherwise, you're degrading your own scientific process.
But I think that you can say that you believe that there's a mediator for light, electricity, and gravity.
Material mediator.
Yeah. Without sacrificing anything, instead of saying that there is an ether.
But that's an ether. You're just avoiding the word for that thing. It's like saying, I believe in Canis familiaris that, lives domesticatedly and but I won't say the word dog. But that's what a dog is.
I don't think so, actually. That's what I'm trying to say is that I think that ether is a particular fluidic approach to the mediator of light and gravity. It comes with that baggage for me, in my experience. At least that's what I feel like rolling around in my mouth when I say the word ether in a conversation with an academic physicist. It brings a lot of the fluidic approach to it, which is not the one that I'm particularly most persuaded of.
Okay.
But I hear what you're saying. Like, if you don't have time to really clarify what you're talking about, you run the risk perhaps of bringing along pieces of the puzzle that might bias someone against following your argument.
It'll just confuse them. But I mean, here's another thing to think about. The people who are just going to immediately write you off for believing in an ether or a mediator, you're not going to convince them anyway. There's huge numbers, and I do believe in convincing people. Like, I mean, that's part of what I'm trying to do. But you cannot sacrifice the message itself, because then what are you even in the business of communicating?
Well, I think that it's a case of leading the horse to water.
Uh-huh.
And the process of leading the horse to water is not by spooking it. And it's like, this is what I mean about psychology being so vital for this, which is the fact that, and it's part of the reason that I feel like I have insights into this is because I grew up in probably the most argumentative household that you could possibly grow up in. Like,
Okay.
Shiloh listens to me having phone calls with my family, and they seem like totally normal phone calls, despite the fact that I have to hold the phone like this far away from my ear, as they just like, there's just some kind of like very intensely debated point. And I get off the phone and he's like, "Was everything okay?" And I'm like, what do you mean?
Is this just a normal conversation?
Yeah. So I'm like deeply argumentative household. And so I feel like I started trying to figure out how to convince people of things and to get them to see some argument early, because it's not just the fact that it's an argumentative household. It's the fact that everybody's incredibly high verbal IQ and incredibly stubborn. And so it's like I started my boss fight of how do you get people to pay attention to something when I was like 6 years old. We're 30 years down the road on this, and I can tell you that it is an unbelievably delicate process of getting somebody to see something that is obvious, that requires not freaking them out. And the word ether freaks people the fuck out.
Right. Yeah, I've definitely experienced that.
And I'm like, and I think that what Shiloh's trying to say is he's like, okay, so the reason that it freaks people out is because they pattern match it onto something that is not what we're talking about. They pattern match it onto this like thing that happened between like 1845 and 1900, where we went from Faraday, who's kind of like first discovering like electromagnetism, and they're like elaborating on the relationships between these things. You have the etherists that are like, oh, it must be the luminiferous ether that's producing these things, but like people weren't really using the word ether prior to that point.
Yeah, not for specifically this thing. Yeah.
Exactly. And so like now that word has been, oh, go ahead. No, go.
Well, I think that in some sense that the approach that the vision they had of that mediator as this fluid bathing stuff that was separate from the atoms, blah, 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 was a huge part of the reason that it failed. Like, I know people point to the Michelson-Morley, but I think conceptually it failed as well. And so that's one thing.
Because really it's not a fluid. There's a lot of evidence that really it's not a fluid that fills space. Rather, it is the universe in some sense. There's a lot of evidence because matter is a wave, because gravitation is a wave, because everything seems to be a wave. It seems to be just one big ether. Incidentally, when I refer to it this way, I actually use the word plenum. Because it's in reference to
Descartes.
So, in reference to Parmenides, as far as I know, because he basically said there is no nothing. He had a very basic argument for this. There is no nothing. Therefore, at any given location, if it looks like there's nothing, there can't be nothing because nothing isn't a thing. Everything that is something. There must be a something at each location. And so he says the universe is full, and plenum comes from the Greek word for full. And so in this I think Parmenides is right about this. And so in this tradition, when I consider the possibility that the ether is really just the whole universe and everything is just really a wave in this ether, all these entities are waves in the ether, I actually refer to it as a plenum to differentiate it from that earlier idea of an ether.
Yeah. And so there's also the fact that it's like, these are topics that are unbelievably esoteric. And so the people that are watching like PBS Space, so like think about it. Like there's a limited number of people that are into this.
Yeah.
More than and that number is much smaller than the number of people that are interested in like the Real Housewives of Beverly Hills. Like that's just... It's just like an inherent feature of nature, right?
Yes.
Like that's just what the topology of the audience landscape looks like. Okay, so there is a very small contingent of people. I always used to joke that it was like roughly the number of people that could fill like a train in New York City in the subway at rush hour who already care about these things and are already convinced that this is the right direction.
Right. Yep.
Very small audience. And yet there's the people that have been listening to like PBS Spacetime and they're kind of like, wait a second, this like doesn't totally add up. I don't really think that these people have answers. And those are the people that need the presentation on like, hey, I know you've been hearing about like fields and black holes and like the fact that photons are super weird and that there's God particles. And I know you're dissatisfied with that. And here is the alternative.
Yeah.
Like, this is why I think the psychology is so important.
The psychology is about communication.
Yes. It's about literally being like, how do you tell somebody something and have them listen?
Yeah.
I hate to say it, I really believe half of science is communication. Like, you can have a brilliant idea. I could totally imagine how everything works, but if I can't get that into your head, then maybe that's, that could be a matter of mathematics. It could be a matter of natural language. It could be a matter of illustration. Whatever it is, like, it's gotta make its way into somebody else's head to be science. Yeah.
Well, I mean, it's still science, even if you're the only one who believes it. But then you just won't get anywhere because you won't. It's just your work, and especially in our, at this stage of science, you need collaboration in order to get very far.
Yeah, so it's like hard to say if it's science if nobody knows what the hell you're on about. Like, could a schizophrenic be like, I understand how light works and it's the goblin gooply guy and it does the thing. It like makes perfect sense to him and he actually sees it perfectly in his head, but he just speaks nonsense. Like,
well, but there's a difference between that person and a lone genius who hasn't been able to communicate his legitimate theory yet.
I'm
not sure.
Yeah,
I think that the act of communicating is the act of thinking in some sense. Like, writing will teach you that, right? Like, you by laying out your ideas, you realize which parts you didn't understand as well as you thought you did when you set out.
That's true, but you're still right if you're right, you're right, even if no one believes you.
This is like a Zen koan. Like, if a tree falls in a forest and there's nobody around to hear it, is it science?
Well, but then no one can. It's not science because no one can describe the thing. But that's not. No one's there to describe the tree falling, so it's not. It's.
I'm not saying it'll be popular,
but that's not really what we're saying.
No. What I'm saying, like,
I think existence has primacy over consciousness. Like, existence exists, and then we're conscious of it.
And
so
I think
but
science is the process of creating a model for existence that is so parsimonious and harmonious with what is actually happening. It is such a good map for the territory that everyone agrees. Like, if you come up with a model,
or at least everyone understands.
Yeah,
I don't care about the agreement personally. I'm just like, if I can say something and you understand what I'm saying and you still disagree, cool. Like, maybe, like, I can be like, hey, gaseous plasmas don't make black body spectrums ever under any conditions. And they can just be like, yeah, I understand what you're saying, but I think they do sometimes. Like, then I'm just like,
if they simply refuse to listen to what you're saying, you're still right. I mean, I don't know if you're right, but like, let's imagine you are. You're right regardless of who understands it. Now, you want to convince people because that is of practical application, but the truth is the core of it all. And this is why I insist on using the word ether, because like that, and it's especially important. To preserve your own grasp of the phenomena, because or to use some similar descriptive word like a plenum.
That's it for the first part of our conversation with James Ellias of the Inductica YouTube channel. If you want to hear about the specifics of what makes for a functional ether theory, then make sure to come back for the back half of the conversation.
See you guys next time.